So welcome back to another video. Today we are doing 69. 69 says four cells, each EMF of 1 point. Each 1.5 V, internal resistance of 4 ohms, internal resistance of 4 ohms are connected in parallel. What is the effective EMF and internal resistance of the combination? What is the effective EMF and the internal resistance of the combination? Alright. Alright, so the question says what is the effective EMF and the internal resistance of the combination? So what we're looking for is the effective EMF. 69. Alright, 4 cells. Don't forget the number of cells is 4. EMF is 1.5 and then the resistance is 4 ohms. Now, the first thing is EMF and effective EMF are the same thing. So the effective EMF is already 1.5. Alright, that's effective EMF. It's the same thing. Now to find the internal resistance of the combination, you are going to say the ohms now. You're going to say the ohms now over the number of cell. The number of cell. So what's the resistance? Resistance R is what? R is 4. What's the number of cell? Number of cells, they say 4 cells. Now be over 4. So you're not seeing the answer. That the answer is what? The answer of this should be D. So I've solved this one to the end for you. EMF is the same thing. When they say effective EMF, is the same output that the EMF will give out. That is the 1.5 volts. When they say find the internal resistance of the combination, it is 4 cells that come to produce that resistance of 4 ohms. You have to divide the 4 ohms by the 4 cells that come together to do it. So if you divide them, you get the resistance of the combination, the internal resistance of the combination to be what? 1 ohm. Alright. So for 71, we are looking for the current of the galvanometer. That's the current of the galvanometer that we are looking for. Alright. So let's take a formula. Let's take a formula sharp now. So the formula we're going to use for this is the galvanometer, the current of the galvanometer, resistance of the galvanometer is equals to current of the ammeter. That is 2 ampere minus current of the galvanometer, which we do not know yet. All in brackets. RS, that's resistance of the shunt. Alright. So this is the formula you have to apply. And this is what you're applying it to. So current of the IG is not there. So we multiply this by current resistance of the galvanometer, which is 5, is equals to the current is 2 minus current of IG is not there. Current of galvanometer is not there. So that's how it to be. Then 0.05. So this is exactly what you are solving. So you solve this, what you get is your answer. You solve this, what you get is your answer. Okay. All right, let's go. So 74. 74. 74 says a radio is operated by eight cells each of EMF 2.0 volts connected in series. If two of the cells are wrongly connected, the net EMF of the radio is what? So what volt will the radio be giving now? They say two are wrongly connected. So 2 from 8 is 6. First of all, you are going to say 8 now is the whole number. But we are removing 2, that is what? 6. So 6 is right. 2 is wrong, right? 6 is right, 2 is wrong. So now what is the voltage? The voltage is what? The voltage is what? 2, right? So what we are going to say is what? 6 that is right, the 6 that is right times 2, that is what? 12 volts. The 2 that is wrong times 2 also, that's what? 4 volts. Eh? Now what we are doing next is to look for the net EMF of the radio. After we've done this now, we'll say 12 minus 4, which will give you what? 8 volts. So 8 volts is the net volt of the radio cell when two cells are wrongly connected. 8 volts is the answer. Thank you.